Okay, we have here another integral on the board. This one's from the University Math Society. This is problem 241. We have the integral of x to the fifth e to the x squared dx. Okay, to get started with this, at first it looks like a good place for us to use integration by parts. The only trouble is just having x squared on the e is going to give us some trouble. So what I want to do before I do integration by parts, let's just try a u substitution to simplify this. So for my u, we'll call that x squared. I'll take a derivative, so du is going to be just 2x dx. And then before we make the substitution, I think what I'm going to do, I'm going to take this x to the fifth and split it up to set this up first. So let's see how this is going to look. So when I do this, I'm just going to I want to create my du at the end, which is just 2x dx. So we're going to set that up for ourselves like this. We'll leave the e to the x squared for now. And then I don't want to change this, so I need to multiply something so that we get back x to the fifth. Well, if I multiply here by half x to the fourth times 2x gives me my x to the fifth, so I haven't changed this. And then one more thing, I'm going to want an expression for x to the fourth, so let's just square this first thing. So if I square this, we get u squared is x to the fourth. So now we have an expression for x to the fourth. Now we'll do the substitution, but I'll take this 1/2 out front of the integral. X to the fourth is going to be u squared. This here is going to be now just e to the u, and this is our du. And now I'll go ahead with integration by parts on this. We'll just use the DI method, tabular integration as kind of a shorthand for integration by parts. And then what I want to do is differentiate u squared because that's going to reduce, and we'll integrate e to the u. So differentiating u squared once, we get 2u. Differentiating one more time, we get a 2. And one more time, differentiating 2, we get 0. Then integrating e to the u is just e to the u, and we'll do that 3 times like that. Now the last row is an integral, but because we're multiplying by 0 here, we can ignore that and we just have our solution here on the diagonals in u. So everything's got an e to the u in it. So when we write this down, I'm going to factor out the e to the u and just write down all this stuff. So we're going to have u squared minus 2u plus 2. Now we can just back substitute to finish this thing off. So we'll have u is x squared, so we're going to have e to the x squared. U squared is x to the fourth using this, minus 2 x squared plus 2. And you know what? I forgot this 1/2 right here. So let's bring that down. We'll just write it in like this, add a plus c, and that's it. Okay, fun problem. We'll stop it there. Thanks everyone for watching. Have a good day.